Let's talk about file mappings. This is not something that you will do often, but it is valuable to know because this concept is used in many things, including graphics programming, and it is the perfect introduction to virtual memory, which we'll talk about for a few videos. So let's go. So a file mapping essentially maps the content of a file into memory, allowing you to directly access the file's content using a pointer. This means that if you write to that memory location, the file will be modified, and if others write to it, you'll be able to see that. If you know something about pointers, you probably know that they are supposed to point into RAM. So how can a pointer point to a file that is stored on disk? In order to understand this, you have to learn what virtual memory is. I already explained this topic in this video, so I'll quickly reuse the explanation from there.
So, do you remember when you learned about pointers and people just told you that they are addresses in RAM? Well, this is actually a lie. You see, there is a level of indirection here. This is all the memory that your program uses, and it is divided into blocks called pages. A page's size differs in each PC, but it is usually 4 kilobytes. Memory addresses are actually pointers to these pages that are later stored in RAM. The program can just read these values, but under the hood, the operating system can move pages wherever he wants in RAM, or even store them in the hard drive. If you allocate some memory but not write to it, the operating system can even pretend that that memory region is allocated, while in fact it isn't.
Okay, now whenever you create a file mapping, that doesn't necessarily mean that the pointer will point to the hard disk. The content of the file will probably be loaded into RAM and copied back into the file when it is changed. This is because the RAM is way faster than the hard disk. It is up to the operating system to do this, and if you choose to map the file that is bigger than your RAM, it might not do it at all, or most probably, just do it in smaller segments. Now let's look at some code. We first create a file, as we did in the last tutorial, but I specified that I would want others to also be able to read and write from it, while I have it open. Then I call create file mapping. This will actually create another object, but not map the memory yet. For this we have to call map view of file. Note that when you call create file mapping, you have to pass the maximum mapping size. And because it's an old Windows function, they split a 64-bit parameter into two 32-bit numbers. Also, note that when you call map view of file, you can specify any offset for the file, and a smaller size if you want. Finally, note that unlike create file A, create file mapping A returns null on failure, not invalid handle value. Now we have our pointer, and here we first write to it, and then we will read from it on a loop. Let's open the created file and modify it. The first thing that you can see is that there are many blank spaces, and that is because we set the size of the file to 100. As you can see, modifying the file will also modify the data in our program. The homework for this video is to make two programs that communicate with each other using this mechanism. You could use two files for this purpose. Don't forget to take into consideration that program 1 might read the content from program 2 before program 2 finishes writing all the content. I will also mention that the guy who made the Handmade Hero series just released an interesting video on this topic, so you might want to check it out. But now, let's learn some more about pages in the next video where we will be allocating memory.